Just continuing on from last lesson's video on theoretical probability and experimental probability, we're going to look at relative frequency now. So if we just recall the formula that we were using, we were looking at the probability of event A occurring. And the probability of a particular event occurring is equal to the number of observed outcomes over number of total outcomes. So in other words, the relative frequency or the probability formula is how many times did that particular thing happen over the total number of times everything has happened. So let's look at a couple of examples to work out what the relative frequency is for this particular diagram. So you can see that there's two cases. There's basket 1 and basket 2, and in each of these baskets there's a particular number of fruits in them, or candies, or cookies. So with this question, my question to you is, first, if we were going to look at the candies, which particular basket do you think has the higher relative frequency? So if we just look at these candy pieces, which one do you think has the higher relative frequency? So I'd like you to just have a think about it and justify your answer, because now we're going to actually have a look at the relative frequencies for each of these cases. So I'm just going to split it down the middle. First, we apply that original probability formula that we had a look at. How many times do you see the apples occurring in this case? I forgot to mention, what we're going to do is we're actually going to calculate the relative frequency for all items. So the apples occur 6 times. The cookies, how many times do you see them occurring? 4. And the candies, they occur 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They occur 10 times. The baskets, you can see that the apples occur twice, and 1, 2, 3, 4, 5, 6, 7. They occur 7 times. So now that we've calculated the actual frequency, let's calculate the relative frequency. So now for the apples, how many times do you see the apples occurring, or observe? How many times do you observe the apples? 6. And how many total items do we have? So 6 plus 4 plus 10. So this would be 20. So our relative frequency for apples is 6 out of 20. Or if we simplify that, because we can half 6 and we can half 20, we can reduce that down to 3 out of 10. If we apply that same thing to the other side, we see the apples observed twice, and out of how many options are there? 1, 2, 3, 4, 11 times. So that's 2 out of 11. Now, let's have a look at the other ones. So let's have a look at the cookies. Cookies, same thing. I'd like you to make sure that you pause the video, and I'd like you to actually calculate the relative frequencies for each of these particular pieces of food. So I'm just going to set it up for you, and I'd like you to pause the video right here and unpause when you have an answer for the relative frequencies for cookies and candies. Alright, now that you've unpaused that, let's have a look at the cookies. So how many cookies do we observe? We observe 4 out of the 20. And we can half 4 and we can half 20, so that reduces down to 2 out of 10. And for our candy, we see that happen 10 out of 20 times. Or in other words, that reduces down to 5 out of 10, because we can half 10 and we can half 20. Now if we look at cookies, we see that happen 2 out of 11 times, and for candy we see it happen 7 out of 11 times. So my question to you at the very start was, which particular basket do you think has the higher relative frequency for candy? So for this, sometimes you'll need to just convert these fractions into decimals because it helps us compare different values. So 3 divided by 10 is 0.30, 2 divided by 10 is 0.20, and 5 divided by 10 is 0.50. Now if we just plug into the calculator what 2 divided by 11 is, we get that it is equal to 0.18. 1818. I'm just going to round it off to 3 decimal places. So again, this is 0.182, and 7 divided by 11 is equal to 0.636. So with this particular case, even though that basket 1 has more pieces of candy than basket 2, the relative frequency of basket 2 is a lot higher than basket 1. So we'll move on to this last example. Calculate the relative frequency of each number on the die rolls to 2 decimal places. So I'd like you to pause this video and I'd like you to actually calculate the relative frequency for each of these particular numbers. So if we roll a 1 on a die, a 2 on a die, 3 on a die, you can see that these are the particular number of times we have observed them. So I'd like you to pause the video and calculate the relative frequency. Okay, so now that you've had a look at it, when we calculate the relative frequency, we first need to calculate the total amount of rolls that we have seen. So if we go 90 plus 49, plus 54, plus 48, plus 52, plus 32, we get a total of 325. So the relative frequency for number 1 is 90 out of 325. This one is 49 out of 325. This one is 54 out of 325. This one's 48 out of 325. 52 out of 325. And this is 32 out of 325. So what I'm going to do is I'm just going to take it a step further. I'm going to represent these particular fractions as decimals so that we can compare each of these rolls. So this is equal to 0.277. 49, so 49 divided by 325, it's equal to 0.15. 1. This is equal to 54 divided by 325. That's equal to 0.166. 48 divided by 325, we get 0.148. Next one, 52 divided by 325, we get 0.16. And for the last one, we get 32 divided by 325, we get 0.98. 0.098, sorry. So if we look at the relative frequencies of these particular rolls, my question to you is this a fair die? In other words, is the proportion, is the relative frequency for each of these rolls equal? The answer for that is no, because you can see that roll number 1, or number 1, that comes up 27% of the time, or 0.277 amount of the times. Whereas if you look at this particular case here, you can see that it comes up 0.09 around the time. And the rest of it looks like it lies between 0.14 and 0.16. So you can see that this is almost the approximately equal part. But these two numbers, the number 1 and number 6, do not have equal relative frequencies. So that recaps the relative frequency formula.